Hi there, welcome to the Simplifying Cypress Testing workshop. I hope everyone is having a great time during the conference. Let me do the following. I'm gonna share my screen here so we can get started. I want your feedback if you can see my screen, if you can hear me well. During the workshop, you should feel free to ask questions at any moment. Eric from the Cypress team is in the backstage collecting all the questions and everything. So it seems that everyone is listening to me correctly and they can see my screen. So thanks for the feedback. So let me give you a little bit of context before we get started. When I was invited to do this workshop here at CypressConf, I thought, well, a workshop usually is not exactly a talk. When you go to a conference, there are lectures that are the talks, you just watch them, and there are also workshops that are more hands-on. But to be it a workshop in an online conference, it would be very hard to make it hands-on for everyone participating into it. So I decided to try something that will be kind of a mix of presentation together with some hands-on parts. So I hope you enjoy it. And the name of this workshop, as you subscribe to it, is Simplifying Cypress Testing. I am Walmyr. I am the founder and instructor at the Talking About Testing online school. I'm super happy to be here with all of you for this third CypressConf. I have the pleasure to be in to be a speaker in the first CypressConf. And I'm glad to be here back again. So let's get started. And I jumped, yeah. So in this workshop, we're gonna cover a few things. So first, we'll cover Cypress versus other test frameworks. Then we'll cover Cypress paradigm shift, Cypress architecture. We'll talk about effective and balanced abstractions in Cypress. There's another very important moment that we'll be talking about selectors, strategies for maintainability, and its key principles. Then we'll talk about the required programming knowledge that is needed for you to use Cypress in a way that allow you to write tests that are robust, that are reliable, yet simple. We'll talk about project organization best practices, and we'll close it out with BDD without the need for Gherkin. So to get started, I want to do a few comparisons here about Cypress versus other test frameworks. So one thing that is important for you to notice when we compare Cypress testing with other frameworks is that Cypress runs in the same browser that the application that you are testing. And this is very important because it gives us many functionalities that I'm going to talk about in a minute that are very powerful for you to write very robust tests and also for you to debug tests when they are failing. There is one point that is very important when we compare Cypress to other frameworks, which is although Cypress uses JavaScript in the background, and so it's asynchronous, although it is asynchronous, you write the code as if it was synchronous because Cypress has a mechanism where it queues the execution of the native Cypress commands. And so it adds them all in a queue, and then it grabs the first one, executes it, and only gets the next one from the queue when the first one has resolved completely. So this allows us to create test commands, test steps, as if they were synchronous, although Cypress is running things asynchronously in the background. But since Cypress uses JavaScript, when you mix JavaScript code with Cypress command, the JavaScript code still runs asynchronously. So if you add like a console log after a few Cypress commands, it will execute even before the Cypress commands because of the asynchronicity of JavaScript itself. Another very important difference of Cypress in comparison to other frameworks is that Cypress has auto-waiting and retriability mechanisms, which means that you don't need to explicitly tell Cypress to wait for the application to be in a specific state before you can interact with an element, you can fill a form, you can click a button or a link or whatever. Cypress automatically waits for the application to be in the correct state so you can start interacting with it. And if things take long to render, Cypress has what they call a retriability mechanism that instead of failing a test immediately when it doesn't find an element, it will retry until it finds it or until it times out, right? So this is a very important difference that other frameworks, at least the old frameworks, don't have. Another difference, setting up a project with Cypress is super straightforward. You basically npm install it, you npx open it, and Cypress bootstraps itself automatically for you, and you can start writing tests. And being easy, and it's not just easy to set up, it's also really easy to debug tests when they fail, because Cypress runs in the same browser as the application that it's testing. And because of that, you have access to everything that you would if you were testing the application in your real browser, where you have access to DevTools, where you have access to the console, where you have access to the DOM, to the network tab, and to everything that the DevTools offers to us. Finally, Cypress has what I call an excellent development experience, or DX. While when we compare Cypress with traditional frameworks, the traditional frameworks, they usually run outside the browser via the network, via some kind of web driver. This is very common in Selenium realm. Many frameworks like Selenium, Playwright, because of the asynchronicity of JavaScript, they run asynchronously and they need to use the async await syntax that came on the more recent versions of JavaScript. Traditional frameworks, they are more complex to set up and to configure usually. So you have to spend quite a lot of time setting it up, configuring everything so you can start writing your tests. While with Cypress, you run 2 commands and you are ready to start testing. In traditional frameworks, you usually have flaky tests, which are the non-deterministic tests, and you have those especially because of timing issues. So because there are many of these other frameworks don't have auto-waiting and retriability mechanisms, you have to explicitly tell the framework, wait for that to be visible, or use async await for things that runs asynchronously to finally happen so you can go to the next step. And they are usually harder to debug due to the poor DX, the poor development experience that they offer. So let's talk a little bit about the paradigm shift that you have when you start using Cypress. I actually forgot to update the title here. It should not be imperative versus declarative testing. I'm going to fix it afterwards when I share the slide. It should be over abstraction versus simpler API. So in traditional testing with other test frameworks, we usually over abstract because we have a complex API. So I don't know if you have used all other test frameworks other than Cypress. I have used many. I have worked with VB script for test automation, I have used Java with Selenium. I have used Selenium with JavaScript. I have used the Ruby on Rails stack for testing, RSpec, Capybara, all that stuff. I have used Playwright. I have used Protractor. When I saw Cypress, I thought to myself, this is different. And they thought really well about the API that they expose to the world so you can be productive writing tests. While other tools, and I am telling you with the experience of someone who has written tests in with other technologies, because they didn't have very easy to understand APIs. And when I'm saying APIs, I'm not talking about REST APIs. I'm talking about the functionalities that the framework offer. Like, so because they didn't have very easy to understand API, I had to create my own abstractions to make the test framework or the tests that I'm writing with a specific framework easy to understand. While Cypler already has a simpler API. And this allows you to write simpler tests. This is something very important. Many people create abstractions with Cypress because, or they were in a world where they used to write abstractions because they used to use frameworks that had very complex APIs, and they bring this approach to Cypress, or because they were told that this is how it's done. But if you look at the Cypress commands API, you see that the commands themselves, they are there. They were very well thought when developed. When you read sci.visit, you understand what it does. It visits a page. When you use sci.get, you understand that you are getting an element. When you do click or type, it's kind of self-explanatory what it does. So there's no real need for you to abstract it away when the API itself is already simple enough. There are cases where you might abstract a few things, but in many cases you might not need it. Okay, so to leverage Cypress' unique capabilities, we have things like time travel with debugging, time travel, which is good for debugging with the snapshots, with like you can see how the app was after it executed. You can see step by step all the states of the application. And you can see like before and after. I'm going to show you that in a moment. You have automatic waiting. So if elements take longer to appear in the screen, Cypress will automatically wait for them before the test fails. Uh, of course, we have the Cypress Cloud, which is an awesome service that allows us to record our testing in the cloud, have analytics information, and now AI powerful features like the sci.prompt that was announced by Brian in the first day. We have network control where we can stub and spy what is going on in the network layer. We have even operating system control via the sci.task command that allows us to run things from the operation system environment directly. Cypress started as an end-to-end testing tool, but now it allows us to write isolated component tests for front-end applications that are using modern test frameworks like React, Angular, Vite, Vue.js, and that kind of stuff. And we have a great command. We have all the commands API that I linked here. You can access the commands API at docs.cypress.io/API/table of contents, where you have access to all the commands that Cypress offers you. And I highly encourage you to read the documents. I remember watching a webinar from Brian Mann a long time ago when I got to know Cypress, and he mentioned that in the beginning, when Cypress was still like in the early versions, that they spent around 40% of the time of building the framework in building a great documentation. So you should take a moment to read the documentation when you are in doubt, because you will find your answer in there most probably. So before we move on to the next slide, I want to switch my screen here to the Cypress app that I have opened. I opened it in a repository that I have the final solution of one of my courses, which is called the Cypress Simulator. And for this course, in the end of the course, we have two test suites, one that runs accessibility tests and one that runs simple end-to-end tests. I'm going to run this one, Cypress Simulator, that runs the end-to-end test, so you can have a look at what I do mean by a great development experience. So while Cypress is running the tests, we see the tests running in the right, and in the left, we see what is called the command logs, where you can see exactly which tests were executed, which scenarios, which test suites. So in this one, we have 3 test suites: Cypress Simulator cookies, consent, and glitch in the matrix. And then we can expand them to see exactly which test cases were inside of each of these test suites. So here we have shows an error when entering and running a valid Cypress command without parentheses. So this application here is an application that I built myself for this course. And the idea of the application is that you would write a Cypress command in this text field here, and you would click run, and it would kind of simulate this command that you would be executing. And when I said about the great development experience, we can see exactly how it was the application when the test started. So we see here as well that we are using session, which allows us to log in, for example, through the UI just once, save the session of the user in the browser, and for all other executions, the Cypress, the test will restore. Cypress will restore the session, so we don't lose time doing things through the UI. So you can see here that a session was restored in this test because I had executed before I started the session here. We can see that after the session was restored, we visited this page, and this is how the application was looking like when this command specifically executed. When we got the text area with the placeholder, write your Cypress code here, it highlights exactly the element that it gets, and you can turn off the highlight if you need to read what it was written inside of it. In this case, nothing was written yet. And then when you use a command like type that has, then you have the before and after functionality. In this one, it's nice to unhighlight because then you can see before and after. So before there was nothing written in the text area, and after we wrote site.visit without opening and closing the parentheses. Then we got the button, then we clicked on it, before and after. After it showed here running, please wait. So it was running something that might take some time, and Cypress was not expecting to see running, please wait. Cypress was expecting to see an error because we are not opening and closing the parentheses when calling site.visit. And Cypress doesn't fail immediately, so it is smart enough to wait for the thing that we want to assert on to appear on the screen. So here we can see that the error has really appeared. The color is not that great, but there is here an error. And then there is a text here saying missing parentheses on site.visit command, and we can assert that this is visible. So I'm not gonna show you all the test cases. I'm just gonna show you one more. Let's see, disable. Disable is clear, doesn't. For example, let me actually go to the accessibility tests here. So this one runs functional tests with Cypress end-to-end tests, and at the same time, it uses Cypress Axe plugin to run accessibility checks during the test execution so we can ensure that the application is accessible. And if we go here for this one that successfully simulates a Cypress command, we can see that we typed in here sci.log and we passed yay inside of it. And after we clicked run, it showed the please wait, but afterwards it showed success, sci.log, logged message, yay. All right. So when I was talking about a great development experience, this is one of the parts of Cypress having a great development experience. Apart from that, if we click inspect, we have access to the DOM, we have access to the console. And if we click in a specific element, we have information about what that command did. So in what element was returned and how many elements were returned for that specific thing. We have access to the source code, to network performance, everything that you would if you were. So for example, the local storage, the cookies, for instance, in here, you have access to everything that you would as if you were testing on your local browser. And this is also great development experience, right? So let's move on here. Now I want to talk a little bit about the Cypress architecture. This is, as far as I know, this diagram here was not created by someone from the Cypress team, but from someone else. But I think it kind of explains really well what Cypress does and how Cypress works. So we have a web browser that communicates. And we have a Node.js process that runs Cypress on it, and we have access to the operating system. And this is kind of a proxy to the browser. And in the browser, we have both Cypress and the application rendered in there, where we have the command logs in the left, the application on the right. And Cypress communicates directly with the application, where we have access to the DOM, to the window, local storage, service worker, and everything. And I think this diagram kind of shows us how Cypress is running exactly in the same run loop as the application and what makes it so powerful. And now I want to mention about effective abstractions in Cypress. And what I'm going to say here might sound weird to many of you, but I think, as I said in the beginning, Cypress is very different from other traditional test frameworks. And because of that, it should be used differently. You shouldn't bring the old school ways of writing tests with Cypress when Cypress has a much better API. So the first recommended abstraction pattern, and actually it's not really an abstraction in this first line here, but the first recommended pattern that I recommend when writing tests with Cypress is writing code inline without abstracting it to a page object, to a custom command, to a helper utility function or anything. Write the code inside all the Cypress commands inside the test file. This is the simplest solution you can use to write simple yet powerful tests, right? Leave to abstract it away to a different place when you need it. Don't try to predict the future. Many people say, oh, I'm going to create this as a custom command or as a page object because if things change in the future, then I have to change just in one place. But what if things don't change in the future? You have created a level of abstraction that wasn't necessary to solve the problem of today. So leave the code inline and abstract away when you need it, not before. This is something that takes time to learn. I am doing test automation for more than 10 years. It took time for me to understand how things can be simpler, because One thing that we have to notice when we are designing automated tests is that the goal is not to write the tests, but to build confidence in the application that we are writing. And I don't know if you have already read unit tests, be them for backend functionality or front-end functionality. But usually in backend tests, you have a few utility functions and you read the code of the test and you see everything that you need in a single file. And this is simpler because you don't have to be navigating from one file to another, to another, to another to understand what a test does. You read one file and you understand what it does without having to navigate to other files. So inline code, in my opinion, is the first recommended pattern that you should use. Then you can start using custom commands for things that make sense, for things that you know that you are going to repeat the thing over and over. Then you abstract it away in a custom command. But for things that you think you will have to reuse in the future, but you don't need to reuse now, just leave it in line. You can leverage Cypress tasks that allows you to run things in the operating system layer. So for instance, if you have a Node.js module that allows you to seed the database with pre-existing test data, you can leverage Cypress tasks for that. You can use what is called abstractions, which is calling the app code from the tests. This might need some effort from the development team to add the testability so you can call the app code from the tests. But this is a very powerful way for you to create the state that you need before for you to create optimized tests where you don't need to spend a lot of time doing things through the UI just to reach a specific state to test a specific scenario that you want. You should use fixtures for mocks and for non-sensitive data. And I put it here in bold because I see in many repositories people adding sensitive data inside fixtures, and fixtures, they are versioned on GitHub. And we should not version sensitive data, any kind of sensitive data, user email, user password, API tokens, that kind of stuff, even if it's just of a sample application. Because if you do it in a sample application, you might forget to do it in a real project, and you might be tracking sensitive data in a repository. Some people might say, oh, but my repository, I can't put sensitive data in there because it's a private repository. Being a private repository doesn't mean it's a hacker cannot get access to it and get access to your credentials. So you should not version sensitive data. So fixtures are for mocks and for non-sensitive test data. For sensitive data, you like secrets, you can use Cypress _ the name of your environment variable on your continuous integration environment. Locally, you can use a cypress.env.json file, which is going to be listed in your git ignore file, so you don't run the risk of tracking sensitive data. Some anti-patterns that I discourage you to do. So I have here over abstraction 1, 2, and 3, and some others. So over abstraction 1, don't create commands like sci.visit products page, which will be basically encapsulating a sci.visit/products. Sci.visit/products is already easy to understand. It's readable. It's clear. There's no need to abstract it away, because then if I need to understand exactly what it does, I have to go to another file. I have to go to the custom commands file to see exactly what visit products page mean. And then I will see that it's just a single line. And then I will think, why do I abstract it away if it's just a single line of code? The same for sci.click login button, which could be a simple sci.contains button login.click. It's straightforward. There's no need to abstract it away to anywhere. Over abstraction 2, hiding test intention. many times when I am reviewing code of my students, I see sometimes they create custom commands to abstract away the assertion of the test. And then if I want to understand exactly what the test is asserting about, I have to go out of the test file to another file to understand what it is asserting. What is it expecting to happen after I do a few actions? I want to read the test file and understand what should happen without having to go anywhere else, without having to access any other file. Last year, I read a book called The Programmer's Brain, something like that, which was written by a Dutch author. And she mentions that our brain has a very small capacity of storing information. And when we are programming, if we have to, and we can store between 5 to 7 things in our brain at the same time. If we have to open many files, we have to store many information, we lose context of what we were seeing in a different file because we overload our brain with more information that it can handle. So don't abstract things that don't need to be abstracted. Over abstraction, 3 complex page objects that are difficult to maintain. So this is back again to what I said before when I started. Like people try to bring patterns from other test frameworks to Cypress when in many cases it might add more complexity than to simplify things. So leave the abstractions for when the code is screaming to you, abstract me away, but not before. Don't try to predict the future. You don't have a crystal ball, no one has. Excessive nesting is also something that you should avoid because it is harder to debug code that has too much nesting on it, and premature abstractions. So premature abstractions is when you try to predict the future. You are abstracting something thinking that you need that abstraction in the future. But since you don't know if you will really need it, don't abstract it prematurely. Leave it to abstract it when the code is screaming to you, abstract me, okay? So continuing here on, when talking about abstractions, I created this graph here, and the numbers are not exact or nothing, but it's just to make a point. So in the x-axis, we have the level of abstraction. Too low abstraction and too high abstraction. So too low in the left, too high in the right, and balanced in the middle. And the y-axis, we have maintainability, where 0 is low maintainability and 100 is high maintainability. It's easier to maintain when it's higher, and it's more difficult to maintain when it's lower. So if you don't have enough abstractions, you have too little abstractions, it might be hard to maintain the code. But when you have too much abstractions, it's also too hard to maintain the code. That might sound counterintuitive, but it's actually true, because I have seen many projects that, like projects, for instance, that use some levels of abstractions, like Gherkin language, which needs step definitions, which sometimes uses page objects, and then then the test fails, and I have to debug what the heck is going on, and then I have to see the feature file, and from the feature file I have to go to the step definition file, and from the step definition file I might have to go to a page objects file, and from the page objects file I might have to go to a selectors file. I have to look into 4 different files just to understand what's going on to fix an issue. So you have to find a balance. You have to find enough abstraction for it not to be too low, but not too high as well. And when you find this balance, then you find a way to easily maintain your task project. Let's talk a little bit about selectors strategy, and then I'm going to show you a project example where I use these abstractions that I am, the selectors strategies that I am talking about here. So selectors strategy for maintainability. In the left, you have what I recommend, and in the right, what you should avoid. So you should use data dash star attributes like data test ID, data QA, or whatever you use in your task project. This is the most reliable way to get an element using Cypress. So you do sci.get, open parentheses. Inside the parentheses, you pass as a string the data test ID attribute of the element with the name of it, with the value of it. And in this case, I would be getting the shopping cart element, for instance, to assert that it's empty or that it has one item in the cart or two or whatever. The other command that I highly recommend using, and I recommend using it this way, is the sci.contains command. People don't see the power of the sci.contains command, but it's a super powerful command. And you can pass to it two. Usually people use it just passing one argument, but the way that I recommend you using it is passing two arguments. The first argument is just a generic selector, just an HTML tag, for instance, or an ID or a class. I prefer using HTML tags because the second argument is what's going to make that generic first argument specific, which is going to be the text that makes the element unique. So for instance, if I want to click, if I want to get a login button, I can say sci.login, first argument as a string button, comma, second argument login. I'm telling Cypress, get a button that contains login on it. And then I could chain a .click, for instance, to click in this command. There are people that use sci.get button.contains login. This makes the code longer and with too many chainings, when you can use just one command that will do the same thing for you in a simpler way. Another way to create very easy to understand selectors is using ARIA label, which is very important when we're talking about accessibility. So if you have an element that has an ARIA label that has a very descriptive text on it, that is going to be read by a screen reader if the application is being used by a person that can see, for instance. So if you read sci.get button with the ARIA label next page, don't you understand exactly what button you are getting? You are getting the button that goes to the next page. So it's very clear, although the selector might be a bit longer, but it tells you what it is. And this is simplicity. And also, if you have an element that has a placeholder, so you can use sci.get, get an input that has the placeholder search emojis. And it's very clear what element you are getting, and there's no need to abstract it away anywhere. It can be inline inside of the test code. What you should avoid generic classes, for instance, btn for button. This is too generic, and you might be getting the wrong element if you use a generic class. Also, classes, they are usually used for CSS styling. So you should not mix testing code with front-end implementation details. Dynamic classes. So the first part of this class here, messenger underscore open button underscore, is static, but what comes next is dynamic. In a different version of the application, this part here might change. And if you select an element by this specific element selector, It might work when you write the test, and when there's a new version of the application, it might break, even though there's nothing wrong with the application. It's just the class that changed the dynamic part of it. Generic selectors with indexes with first or last. Sci.get a first. You get the first link. It's too generic. You don't know if you are getting the right anchor element. Or sci.get button dot EQ3. You are getting the fourth button. What if there is a change that adds a button before the third one, and then the fourth one, and then the fourth one becomes the fifth? Then your test will break, even though the application could not be broken. Or long and hard to read selectors. So don't use things like this sci.get div inside, then p, then span, npf, child two. So this selector is difficult to understand if you don't have enough knowledge of CSS selection. So this is telling Cypress, get the second span that is a direct child of a paragraph, that is a direct child of a div. But it's not clear when you read it. It's not like very descriptive. And XPath, simply don't use it. Instead of it, you should learn CSS for real. And for that, I have a link here that I'm gonna, all the links that I'm gonna show here, I'm gonna send to the Cypress team afterwards so they can send you all. So I created this, not this one, it's, yeah, it's this one, yeah. So master CSS selectors I created using Lovable. It has basic selectors, attribute selectors, pseudo class selectors, combinator selectors, advanced selectors, everything you need to learn the basics of CSS selection with real examples that you can copy and paste and try it out yourself. So to wrap up with regards to selectors, strategies and key principles, selectors should be resilient to UI changes. When you change a class in the application, it should not break your tests. Selectors should review intent, not implementation details. So when you use ARIA label, placeholder, that kind of thing, you are revealing the intent of what the element does without being telling an element that has a specific class that is used for styling, for example. Selectors should be consistent across the entire project. So when you define a selector as a strategy, try to use it everywhere so you have a standard, let's say. And finally, selectors should be simple. So keep it simple. I know that we have just a bit less than 20 minutes, so I'm gonna try to go a bit faster here. So many people say that Cypress has a very low learning curve, and so you should not have a very high, you don't need to have very high programming skills. I say that the more skills you have in programming, the better tests you write. So you should have knowledge not only of a programming language, but also of the technologies that run in the browser. So you should know HTML5, you should know CSS3, you should know JavaScript fundamentals, and you should know at least the most recent features that came in 2015 with ECMAScript 6. So you should know about asynchronous programming and promises. You should know how to manipulate the DOM. You should know some basic debugging techniques like how do I stop my code in a specific command so I can continue from there and explore what's going on? How can I log information in the console and that kind of thing? So programming is very important. The more you know programming, better tests you write. And to help you with that, I have created, as I created master CSS selectors, I've created also a master JavaScript, which explains the concept, the very basic concepts of JavaScript, like variables and data types, functions, arrays and objects, async programming, DOM manipulation, ES6 plus features, and you have it here all. I'm going to share the links afterwards, as I said. I don't think I mentioned in the slides, but I'm going to share also this one called Terminal Quest, which has basic knowledge of command line interface, as well as Git commands, so Git basics, advanced Git, and so on and so forth. Let's go back here. So to bridge the gap, if you say, I don't have enough programming knowledge, what I recommend you to do, read the official docs of the tools that you are using, not only Cypress, read Mozilla docs, read W3C, read the docs. You'll find the information that you need in them. Do pair programming sessions with more experienced testers and or developers. Pair programming is a great way for you to learn from more experienced people than you. Ask for code reviews focused on test design patterns and practice. You need hands-on practice to master programming. There's no other way. I have been programming for more than 10 years. This is why, to me, nowadays, it's simpler. It's simple, but it wasn't in the beginning. But because I kept practicing, it became simpler. Prioritize readability versus dry code. So when I say prioritize readability, you should prioritize readability when tests serve as documentation, when the team have a mixed experience level, when debugging failed tests, and when onboarding new team members. So this is an example of a code that is very easy to read, but it might not be dry. So I am using like inline code, site.visit/login site.get, an element that has a data test ID, username, and typing test user on it. I'm getting the password field and I'm typing secret password. I'm getting the login button and I'm clicking on it, and I'm getting the URL to see that it includes dashboard, meaning that I was redirected to the right place. On the other side, we have dry code. And you should prioritize dry code when you have repetitive test patterns, when you have complex setup procedures, when you want to maintain a large test suite, and when the team has a strong programming skill. Because when you write dry code, you are creating abstractions, and abstractions create complexity. They add complexity to the code. So this is a custom command that does login, receiving a user and a password, but in the end, it's actually using Cypress session, site.session, to create the session once and restore the session afterwards if the session is already created. This is more complex because you need to know the Cypress module that has the commands module inside of it, that has the add function inside of it. You need to know how to create a function. You need to understand about variables, so you need to know programming. This is a variable that is receiving a function that has the exact same steps as we saw before, and then we are passing to site.session the username, which is an argument that we received here, and we are also passing the setup function, which is a variable that we created and stored an arrow function inside of it. And after that, we use site.visit, and this is the implementation details of a custom command, and this is how you would use it. You would say site.login, and you would pass the first argument that it expects is a username, which you would grab from an environment variable that is secure, and the same for the password. But you need to know how to do that. You need to understand Cypress.env to use it. So it's more complex, although you might, but it's worth, because logging is something that you will repeat all over, and you don't want to write all these 5 lines all over. You want to write it once, and if it changes, you can change it in a single place. But for things that are not being repeated all over, leave it in line. Project organization best practices. The recommended project structure that I recommend is basically what Cypress offers out of the box with just a few modifications, like group tests by feature or domain, separate test data from test logic, and set centralized reusable commands. So you have your Cypress config file, and you have your Cypress directory. Inside of it, you have your end-to-end directory where you have your end-to-end tests. And inside of it, you can have subfolders for authentication, where inside auth, you have the login.site.js tests. Inside dashboard, you would have the tests for that specific functionality. You would have inside the Cypress directory the fixtures directory for your test data, for mocks and that kind of thing. And inside the support, you would have shared utilities. In the commands file, you would have your own custom commands. In the end-to-end.js file, you could import external libraries that would be available when Cypress starts running. Also about project organization, the recommended configuration that I use is define a base URL in your config file, define environment-specific settings, and plugins to extend functionality. In this example here, it's just a basic base URL and environment-specific settings, no plugins in here, but you could need extend Cypress features to do other stuff. As for example, when I used Cypress Axe to do accessibility testing, you would have maybe to change the config file or the Cypress/support/e2e.js file, read the docs, understand where you have to put the imports and that kind of thing, and put it there. But use the base URL pointing to the default URL that you would be testing. Create an env for the API URL. This is important because then you can write the same test, you can run the same tests against different environments. So when you run it with the default information, it will run with the front end running on localhost on port 3000, and with the backend running in the port in 3001. But if you want to run the same task against a staging environment, you would just overwrite the base URL and the API environment through a command line interface, which would allow you to run the same tests against different environments without having to change a line of code. Finally, I said that we would talk about BDD without Gherkin. So the BDD principles in Cypress is that you should focus on behavior, not implementation. You should use clear descriptions for suites and test cases. You should structure tests as user journeys, and you should maintain a stakeholder-friendly language. And how do you do BDD without Gherkin? You can use native Cypress commands like describe shopping cart, that has a test case, increases the cart count when adding a product to it, that use site.visit/products, site contains button add cart.click, site.get data test ID cart counter should contain 1. And on top of the commands, you can add comments given the user is on the products page. When they add the product to the cart, then the cart count should increase in 1. And you don't need to have it in one file and the implementation in another and other details in a page object and the selectors in a different file. You have everything in one file. It's easy to read for technical person because Cypress commands are simple, and it's easy to read for a non-technical person because there are comments telling what the commands do. So the benefits of the Cypress native approach: reduced syntax overhead and issues, better IDE integration, easier debugging, simpler onboarding for developers. I created this graph here to show you that here we have a score from 0 to 10. 0 means that it's bad, 10 means it's good, and the blue charts, the blue bars are Gherkin, the green bars are native Cypress. So when you use Gherkin, in terms of development experience, you lose a lot. While when you use native Cypress command, you have a great development experience. In terms of readability, this is the only one that Gherkin wins Cypress, because it's like reading Gherkin, it's very readable, like it's natural language. So you can't beat that. But still, reading Cypress code is not as hard as it would be to read a feature file. It's a little bit easier, but it's not like feature file is a little bit easier, but it's not super much easier than just reading native Cypress commands. Maintenance is much better when you use native Cypress commands instead of using Gherkin, because you have lots of different files that you have to navigate through to understand what is going on. And the setup is also much simpler when you use native Cypress, because then you don't need to configure Gherkin. Basically, you don't have to configure Cypress Cucumber plugin and that kind of thing. Let me show you very quickly here something that I have done. I have done an experiment, a scientific experiment. I created this project, Cucumber Salad, on my GitHub. It's public. And in this one, there is, like in the main branch, I am using Cucumber. So if we go, for instance, here, for this one, for instance, we have some feature files here written in Gherkin. Given access the Engage Sphere app without any cookies set, and I see the cookies consent banner. When I click the accept button, then the cookies banner is closed, and the cookie consent cookie is set with the value accepted. Very easy to understand. But you still have to write the step definitions that map that natural language to Cypress commands. I have created in a different range a simpler solution where you have just the Cypress file with the comments given I access something and the command that does it directly in the code. It's super simple. But the thing that I wanted to show you is that if we go to the list of commits here and we look into the implement simplified version and we click on it, you see that this change deleted 200 lines of code and added 141. So we saved 59 lines of code by removing Gherkin from this project. And this is a small project. Imagine in a bigger scale how much simpler a project could be if you were not using Gherkin. Besides that, if we go back to the list of commits, I used another commit for the package lock.json. This one we saved almost 4.5 thousand lines of code. I removed almost 5,000 lines of code and I added only 200 and something. So because I'm not using in this specific branch the Cucumber plugin. So I want to show you that because it was a scientific experiment that I really wanted to do for a long time, and to show people that things can be much simpler when you write Cypress tests without the Gherkin language and without the Cucumber plugin. So some takeaways here. Cypress requires a different testing mindset. You should choose the right amount of abstraction for your team, but don't over-abstract. The readability and dry code principles should be balanced based on your context, and BDD can be implemented without Gherkin syntax. The next steps that I recommend to you is review and adapt your existing test strategy based on what you saw here that could make sense to you. Start with small focused Cypress tests and then move over. Gradually build your abstractions pattern. Don't try to predict the future. Build abstractions when they are screaming to you, abstract me away. And share knowledge across your team and community, because as I said before, the goal is not to write tests, but to build confidence in your application. I don't know if we will have time for questions because we are almost over. But if you want to reach out to me to ask questions about Cypress testing approaches, abstractions, testing strategies, test design, or even implementation details, I'll be happy to answer. And if we don't have time to do that in here, here is my website, walmyr.dev, is WALMYR.dev. In there, you'll find link to my online school, you'll find link to my GitHub, to my LinkedIn, where you can connect with me, to reach out, to give me feedback about this workshop. I hope you liked it. And we have just one more minute. Do you think we could have at least one question answered here, Eric? I organized the Cypress with page objects model being a class consists of selectors and actions. Any comments on that style of managing big Cypress project against a big web app? I would recommend you understand if the page objects that you are creating are actually needed. And another thing that I would recommend is that instead of using classes and object-oriented approach for creating your page objects, try using functional approach, which is much simpler. You use much less syntax overhead. With you don't need to use class keyword, you don't need to use extends keyword, you don't need to use super and new and all that JavaScript syntax that comes when you write object-oriented code. So I hope this answers your question. But if you want to have more deeper answer, you can reach out to me on LinkedIn. I think we are done here. I hope you enjoyed it, and I hope to see you next year on CypressConf 2026. Cheers.